Hello dear students. Today we will discuss the preparation of salts in that the baking soda. So this baking soda is generally called as a baking powder with the general formula NaHCO3. It is called as sodium bicarbonate or sodium hydrogen carbonate. So this baking soda mainly is used in the preparation of cakes or preparation of buns in the bakeries. So that we will discuss later. How does this baking powder or baking soda is going to be prepared? It is very important. Simple steps are there. Let us go with that simple steps. So initially, if you wanted to prepare the baking soda, so you need to take a cold sodium chloride solution, which is called as brine. That already we have discussed it. Sodium chloride, if it is mixed with water, if it is dissolved in the water, so that solution we are calling it as brine solution. Okay, so cold brine solution, which is having the highest concentrated cold and concentrated brine solution is taken. To this we are going to add, it is reacted with ammonia and even though carbon dioxide gas. It is passed over with the carbon dioxide gas. Then what happens? What is the reaction here is? So this is going to form sodium bicarbonate. It is going to form sodium bicarbonate with that ammonium chloride NH4Cl is going to be getting as a byproduct. So this ammonium chloride is dissolved in water as we have reacted. It is sodium chloride is mixed with the water. Ammonium chloride we are going to get as a byproduct which is dissolved in the water which is in a solution state. And when you come with the sodium bicarbonate, this sodium bicarbonate is slightly soluble in water and it is going to form a precipitate upon the water. So it will be in the solid form. A precipitation, already you know, if a precipitation form is there, means an insoluble solid is going to form in the reaction. So sodium bicarbonate is in the form of precipitate, so that can be filtered. It is further filtered and extracted from the solution. So this is a simple method to prepare baking soda. So again I am repeating, when the sodium chloride is dissolved in water, a cold and concentrated sodium chloride solution is taken. To that sodium chloride solution we are going to pass ammonia gas and carbon dioxide gas. When both of these are going to react with the sodium chloride solution, then we are getting sodium hydrogen carbonate. Sodium hydrogen carbonate or sodium bicarbonate, which is commonly called as baking soda. And another byproduct we got here is called as ammonium chloride, which is in a solution state. It is completely dissolved in water, it will be in the solution state, and sodium bicarbonate will be in the precipitate form. So this precipitate is filtered. Later it is filtered and it is taken out as a solid state. So that is nothing but your preparation of a baking soda. So this, after this baking soda, another we are going to take the preparation of washing soda. Preparation of washing soda. So this preparation, it is similar to the preparation of a baking soda. As same steps I am going to take here. Whenever we are going to take sodium chloride NaCl with that water molecule is there, so both are reacted with ammonia gas and carbon dioxide gas. It is going to form sodium hydrogen carbonate. Sodium hydrogen carbonate with that ammonium chloride will be separated outside. Ammonium chloride separated. This sodium bicarbonate NaHCO3 is taken and it is heated. Okay, whenever it is heated, what happens means the hydrogen and the oxygen which is present here, both they will combine together. Okay, and it is going to form sodium carbonate Na2CO3 plus H2O. So here sodium hydrogen carbonate is prepared by using a similar process what we have taken in the baking soda. Then that sodium bicarbonate, after drying, first you will go to filtration process. After filtration you are going to get a solid substance. That solid substance is dried completely. Then it is taken. So here sodium bicarbonate is there. this sodium bicarbonate is further heated. After heating, we are going to get sodium carbonate and water molecule. If the sodium carbonate is in the absence of water, if any water molecule is not attached to the sodium carbonate, means we can say them any salts. Any salts, if the water molecule is not attached to the salts, means then that type of salts are called as anhydrous salts. If a water molecule is attached to the salt, then those are called as hydrated salts. So here sodium carbonate, only sodium carbonate is there and there is no water molecule. Water molecule is not attached to the salt here. So that we will discuss later in the water of crystallinity or water of crystallization. Sodium carbonate in the absence of water, then it is completely anhydrous sodium carbonate. So this anhydrous sodium carbonate is also called as soda ash. It is also called as soda ash. Then that soda ash, sodium Na2CO3 is taken. To this sodium carbonate is dissolved in some amount of water molecule or water. 10 molecules of water will get attached to the sodium carbonate and it is going to form Na2CO3 or 10H2O, which is called as sodium carbonate decahydrate. Sodium carbonate decahydrate. If a water molecule is absent, that is called as soda ash. If water molecule is attached to the sodium carbonate, then that is called as washing soda, which is also called as sodium carbonate decahydrate. Okay, I hope it's the name sodium carbonate decahydrate. Hope you understood. So initially we will take sodium chloride and water solution. Sodium chloride solution, to that ammonia gas is passed, then carbon dioxide gas is passed. Both they will react with the salt solution and it is going to form sodium bicarbonate, which is called as baking soda. Already what we have discussed in the earlier reaction. So that sodium bicarbonate is taken and it is heated. Whenever the sodium bicarbonate is heated, water molecule will get separated and it is going to form sodium carbonate in the absence of water. There is no molecule of water is not attached here. So it is called as soda ash. Generally it is called as soda ash. Then that soda ash, sodium carbonate is taken and it is dissolved in water. When it is dissolved in water, so 10 molecules of water will get attached to the sodium carbonate. Then it is going to form sodium carbonate decahydrate, which is generally called as washing soda. So this washing soda is used as a cleansing agent. So that only we are using for the cleansing actions. Next, let us go with the next one. It is about plaster of Paris and the preparation of plaster of Paris. As you know that this plaster of Paris is much useful in the medicine field, where if the fractured bones are there, that fractured bones are fixed by using this plaster of Paris. Okay, so when you come with the preparation of this plaster of Paris, mainly you should know about the calcium sulfate, which is consisting of 2 molecules of water. So this plaster of Paris is prepared by using calcium sulfate with the 2 molecules of water molecule. 2 molecules of water is attached to calcium sulfate and it is generally called as gypsum. So this gypsum, it is heated at 100 degrees Celsius. It is heated at 100 degrees Celsius or 373 Kelvin. It is heated at 100 degrees Celsius. When it is heated at 100 degrees Celsius, 1.5 molecules of water will get evaporated or it is getting separated outside and only half molecules of water will be attached to the calcium sulfate. So here 3/4 of water molecule will be completely liberated. So like I will write here, see, when the calcium sulfate is heated, this calcium sulfate will be consisting only of molecules of water. Only of molecules of water. With that, 1.5 molecules of water will get evaporated outside. 1.5 molecules of water will be completely liberated outside. So this calcium sulfate with of molecules of water is called as calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Hemi in the sense of molecules of water. So here two molecules are there. These two molecules is nothing but bihydrate or dihydrate. Calcium sulfate, dihydrate or bihydrate. It is heated at 100 degrees Celsius, exactly at 100 degrees Celsius. If you increase it more, if the temperature is increased more than 100 degrees Celsius, means we are not going to get a calcium sulfate with of molecules. So completely water will get evaporated and calcium sulfate will get harder. Okay. Due to that, always fix the temperature. It should be 100 degrees Celsius or 373 Kelvin. When you heat it at that temperature, the calcium sulfate, 1.5 molecules of water will be liberating or it will be separated outside, and only of molecules of water will get attached to calcium sulfate, which is called as calcium sulfate hemihydrate, and 1.5 molecules of water will evaporate outside. So this is nothing but your plaster of Paris. So this plaster of Paris is mainly used in the fixing of fractured bones. Okay, and number of examples are there. Even though we can prepare toys, any like idols in temple, mainly in temples, they are going to prepare the idols, god idols. That for that mainly this plaster of Paris is used here. And number of examples, number of uses I have given in the worksheet. Just to go with the worksheets there. Okay, and the next one we are having water of crystallinity, water of crystallization or water of crystallinity. So this water of crystallization in the sense, the fixed amount of fixed number of water molecules will be attached to one formula unit of salt. Fixed amount of water molecules will be attached to one formula unit of salt. That is nothing but water of crystallinity or water of crystallization. For example, here we have to calcium sulfate with 2 molecules of water. So this 2 molecule of water is nothing but it is the water of crystallinity for calcium sulfate. So here water molecules which is attached to any salt, it is going to give the shape and size of that salt. It is going to give the shape and size of that salt, even though it is going to give the color of the salt. It is going to change the color of the salt. If a salt is attached with the water, those type of salts are called as hydrated salts. Already I said, if a water molecule is attached with the salts, those type of salts are called as hydrated. They are called as hydrated salts. And if water molecule is not attached to the salts, then those are called as anhydrous or anhydrous salts. So when I was saying about sodium chloride, Na2CO3, if it is not attached with the water molecule, completely these type of salts are called as anhydrous salts. If water molecule is attached, even though plaster of Paris is there, so half molecules of water is attached. So this also we can take it as a water of crystallization. So here water of crystallization is nothing but the maximum or minimum amount of water molecule which is attached to one formula unit of salt, that is called as water of crystallization. Simple example I will give you here. Copper sulfate. To this copper sulfate, 5 molecules of water is attached. When the water molecule is attached, it will be having a definite shape and definite size. It will be in a crystal form and it is also going to give a color. So copper sulfate will be in a blue color. It is called as, generally it is called as blue vitriol. Okay, and even if you are taking iron sulfate, FeSO4 with 7 molecules of water is attached. When the 7 molecules of water is attached, then it is going to show light green color. Generally we can call this as green vitriol. Okay, so like that, the number of water molecule which is attached to any salts, one formula unit of salt, and that water molecule is going to give the shape and size. It is going to give the crystal nature to the soil, and even though it is going to give the color to the soil. So that process, that one is nothing but water of crystallization. Okay dear students, hope you understood about these preparations, and uses I didn't explain any uses here because I have given you the worksheets. You can go with the worksheets and note down all the uses for a different salts what we have discussed in the last classes. So this is about your preparation of salts.